This is a lecture from Open Tuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
Forecasting techniques, and this one is something called time series, which is rather different from the previous two. The previous two, high-low and regression, from a management accounting point of view, are useful in forecasting costs when we've got semi-variable costs. The time series analysis is more useful when we're trying to forecast sales. Because it's very common if we're trying to forecast sales for next year, a very common way to approach it is to look at sales in previous years. You see people with graphs of previous year's sales and trying to extrapolate, trying to project into the future to forecast. But what time series is doing, again, we are going to try and forecast sales based on past sales, but it's relevant when we've got what we call seasonality. And to explain what I mean, can you go straight to example 5, or exercise 5, I'm sorry. It says, set out below are the sales per quarter in thousands of units of a company over the last 3 years. So you've got 3 years there, 2000, 2001, 2002. There are sales per quarter, and overall they do appear to be going up. The first quarter of 2000 was 80. By the time we get to the fourth quarter of 2002, they're 116. So it does look as though sales are increasing over time. However, if you look in more detail, the first year, quarter 1 was 80, quarter 2, a lot higher, 87. Quarter 3 goes down to 82, quarter 4 it goes up again. Look at 2001. It's 90, then it goes up in quarter 2, it goes down in quarter 3, up again in quarter 4. And 2002, 105, it goes up, it goes down, it goes up again. It does look as though we've got seasonality, perhaps we're selling ice cream or umbrellas or something. But it does seem as though we always go up in quarter 2, it always drops in quarter 3, it goes up in quarter 4, and then it drops again in quarter 1. And so what would be rather nice if we were trying to forecast into the future, would be able, depending on whether, next year, whether I'm forecasting quarter 1 or quarter 2, to take account of the fact that although on the one hand sales seem to be increasing overall, but at the same time in individual quarters, some quarters they may be higher than usual, some quarters lower. So that's what we're going to do. It's very much a speed calculation exercise. Let's do it, I'll explain as we go through. First of all, let's list our unit sales as a column. In order, so first year's 2000, quarter 1 was 80, quarter 2, 87, quarter 3, 82, quarter 4, 90. In 2001, 90, 95, 93, 102. In 2002, 105, idiot. 1, 2, 3, 4. In 2002, it's 105, 112, 103, 116. So there we are. Well, first of all, I want to try and find out what you might call the underlying pattern of the sales. You see, again, we're not going to draw graphs, but if I did put these on a graph, the sales seem to be going up, up, down, up, down, up, down, up, down, up, down. It's very hard to forecast in the future. What we're going to do first is try and find what you might call the underlying pattern of sales if there wasn't this seasonality, if you didn't have some quarters up, some quarters down. And we do that by averaging. The seasonality is over the year, over 4 quarters. So in the year 2000, the first 4 quarters, all right, some quarters were up on average, some were down. But let's work out the average sales for those 4 quarters. So the average, simply add them up and divide by 4. 80 plus 87 plus 82 plus 90. Divide by 4, I get 84.75, and I'll write that straight in the middle. I'll put it in the middle of the year, because remember, overall things are increasing, so if it wasn't the up, down, I'd expect earlier quarters to be a bit less, later quarters to be a bit more. The average, though, 84.75. Well, let's take the next 12-month period. Let's take these 12 months, 4 quarters, and let's work out what the average sales were over those 4 quarters. So 87 plus 82, 90, 90. Divide by 4, I get 87.25. So that's like the average in the middle of that year, of those 12 months. And we keep doing it. So that first one was sort of in the middle of that first 12 months, second 12 months. What about the next 4, which is from there to there? Add them up and divide by 4, 82 plus 90 plus 90 plus 95. Divide by 4 is 89.25, and so on. So I won't keep talking through them. See how fast we can be. The next 12 months is from there to there. 90 plus 90 plus 95 plus 93 divided by 4. That's a good start. 90 plus 90 plus 95 plus 93 divided by 4. I get 92. The next one. 95. The next one, 95 plus 93 plus 102 plus 105. 98.75. Nearly there. Next one, 93, 102, 105, 112. 103.75. Is that right? 93, 102, 105, 112. No, 103. Next one, 102, 105, 112, 103. 105.5. And the last one, the last 12-month period. 109. So I hope it was clear what I was doing. The average for each successive 12-month period. And we call that the moving average. And look at it now, because we've kept averaging, the seasonal variations have disappeared, and there is a much smoother pattern of sales. Remember, I'm trying to find, first of all, the underlying pattern of sales. However, what would also be very nice is if I could start to measure the seasonal variations themselves. And the problem I've got all these averages, but that first one, for instance, didn't correspond to any particular quarter. It was bang in the middle of the year. What I'm getting at, you see, if I had drawn a sort of histogram, quarter 1, the sales were 80, Quarter 2, they were 87. Quarter 3, they were 82. Quarter 4, they were 90. And the first quarter of the following year, they were 90. And what I've done, I've taken an average of the first 4 quarters, and you see, had there not been seasonality, the sales presumably would have been increasing quite smoothly. But I just got the overall average, which is sort of bang in the middle of the year. And for the next one, again, I've got bang in the middle of the next 4 years. They don't actually correspond to any particular quarter. And so what we do is what we call centre the average. And what you do, we take the first 2 moving averages, those 2, and we say, what's the average of them? Well, add them up and divide by 2. 84.75 plus 87.25 divided by 2, it's 86. But what I mean by centred it is that's now given as an average in the middle that corresponds to an actual quarter. We're saying the actual sales in quarter 3 were 82, but we're now saying that if sales had been moving smoothly, there'd been no seasonality, it would be 86. And for the next quarter, we take the next 2. We take these 2, 87.25 plus 89.25, divide by 2 to average, and I get 88.25. That corresponds to quarter 4 of the first year. And we carry on doing it for all of them. So the next 2, 89.25 plus 92 divided by 2 to get the average is 90.625. I'm not going to mess around having 3 decimal places. Well, that corresponds to quarter 1. The next 2, 92 plus 95 divided by 2 is 93.5. The next 2, 95 plus 98.75, 96.87. The next 2, 100.87. The next 2, 104.25, and finally uh, 107.25. Right. So I did say a few minutes ago, it's not hard, but it's just time consuming, it can't go to speed. What have we got there? What we've now got, forgetting the first and last 2 quarters, we can't fit them in. There'll be no way of comparing them. But for all the other quarters, in the first column are what the sales actually were. Some quarters higher, some quarters lower. In this final column, or the latest column, the centred average, what we've got there is what the sales would have been per quarter if there had been no seasonality. And we call this the trend. The trend, the centred average, but the trend is the underlying pattern of sales, which I did say, I've cleared off my graph, I did say it's what we're looking for. The original pattern was up, down, up, down, up, down. We've now smoothed it out. If you put those figures on a graph, I'm sure you can accept by looking at them, you'd be a lot smoother. It'd be a lot easier, perhaps, to forecast to continue into the future. And we could forecast the trend. But it'd be also rather nice, would it not? We could forecast, we could even use regression on those figures, but we could forecast, if it was just drawing it on a board, you know, it seemed to be fairly smooth, forecasting the future, but it'd be rather nice to be able to forecast for particular quarters. And we know that quarter 2 is always higher and quarter 3 is always lower, and so on. So it'd be nice to forecast what the seasonal change was. And so we're going to look at one more thing. Now, there are two ways of doing this, but the first way is something we call the additive model. But we're going to look at the seasonal variation. I'll write the name of it after. And what we do is for each quarter, we compare the actual sales with the trend and look to see how much they were up or down. Now, I can't compare quarters 1 and 2, nothing to compare with, but quarter 3, the actual was 82, the trend was 86, so we were down 4 on the average on the trend. Quarter 4, the actual was 90, so compared with the trend, it was up 1.75. Quarter 1 of the next year, 90 is against 90.62, it was down 0.62. Quarter 2, 95 minus 93 is up 1.5. Quarter 3, 93 down to it's down 3.87. Quarter 4 is up 1.13. Quarter 1 is up 0.75. Quarter 2 is up 4.75. Now, if things aren't perfect here, clearly, quarter 3 is down 4, it's down 387. So it's not always the same, but it seems reasonable. Quarter 4 is up a bit there, quarter 4 is up a bit there, okay. Quarter 1, down a tiny bit, up a tiny bit. So seasonal variation isn't precise. And finally, quarter 2, up 1.5, up 4.5. No, it's not precise. And so, because it's not, things aren't working perfectly, we can work out for each quarter what the average seasonal variations are. And so, a little bit of workings here. We've got 4 quarters. And what were the variations? Well, in the first year, 2000, nothing for the first 2, but quarter 3 was down 4. Quarter 4 was up 1.75. For 2001, quarter 1 was down 0.62, up 1.5, down 3.87, up 1.13. And 2002, quarter 1 was up 0.75, up 4.75, with nothing for the other 2. And so let's work out the average seasonal variation in each quarter. Quarter 1, add them up and divide by 2. So it's plus 0.75 minus 0.62 divided by 2 is plus 0.06. Quarter 2, 1.5 plus 4.75 divided by 2 is plus 3.12. Quarter 4, minus 4 minus 3.87 divided by 2 is minus, oh, my fingers went wrong, minus 3.93. And finally, quarter 4 up 1.44. So there's the average variation for each of the 4 quarters. Now here we've looked at very few. In real life, I'd want to look at far more years, you know, and have a much, I was going to say accurate average. It's not a question of being accurate. I think you know what I'm getting at. One small point before I tell you how we use this. What do you think? Those 4 seasonal variations, what do you think they should add up to? All right. Ideally, this should add up to 0 if you think about it, because you know, you're either up on average or you're down on average. Because it's either side of averages, they should add up to 0, do they? Plus 0.06 plus 3.12 minus 3.93 plus 1.44, they actually add up to plus 0.69. They don't add up to 0. And the reason is, it's because the first 2 and the last 2 sales, they were used in calculating our averages, but then we've nothing to compare with the seasonal variation. If we'd looked at the last 10 years, then you'd find the seasonal variations, they would add up to much, much closer to 0. So it's a minor point. In a sort of perfect world, they'd add up to 0. Finally, though, here, how would you actually use it? What's the relevance of all we've done? What we'd do is we'd forecast the trend for a future quarter. I said at the time, the trend we arrived at is a lot smoother. So maybe we use a graph and just extend it, extrapolate, or use something like regression on it if it was more or less linear. But having forecast sales for quarter 3 of next year or something, we then adjust by the relevant seasonal variation. And so if I'd forecast the trend for quarter 2 of next year, I then add 3.12, because we know quarter 2 on average is 3.12 higher than the trend. So that's quite jolly. However, just one final thing here. We're going to forecast the trend and then forecast the variation. But think about this. If the sales are growing a lot, then, all right, quarter 2, you may always expect it to be higher than average. But if the sales themselves are growing, I think I'd expect the variation to grow as well. So, you know, if sales next year were twice as high, wouldn't I expect the variation to be twice as high? Whereas on the way we've done it here, even if the trend was twice as high, we'd still just add on 3.12. We'd still add on the same variation. And so it's an alternative way of dealing with the seasonal variation. The way we've done it is called the additive model. The alternative, which won't take many minutes, don't worry, but the alternative, to take account of what I just said, is to ignore that and instead use what we call the multiplicative. Well, I managed to spell it. the multiplicative model. And what we do instead, we're still going to compare the actual figure with the trend. But instead of just looking at the difference of 4 or whatever it is, we do it as a percentage. We take the actual divided by the trend as a percent. And so work through with me. Quarter 3, the first one, 82 divided by 86. The actual was 95.3% of the trend. Quarter 4, 90 divided by 88.25. It was 102, if I keep to one decimal place, percent of the trend. Following quarter 1, 90 divided by 90.62, 99%. Next one, where am I up to? 95 divided by 93.5, 101.6%. Next, 93, 96.87. 96%, 102, 101.1%, 105, 104.25 is 100.7%, and finally 112 divided by 107.25. 104.4%. So sorry, I'm being a bit messy there, but still. So instead of looking at the absolute difference as we did in the additive model, actual is a percent of trend. And then, in the same way as we did before, because the variation is changing, it's not perfect, it's not the same in each quarter, we can average out. So if I take the averages of these percentages, the first year, nothing for the first 2, but then it was 95.3 and 102. In the second year, it was 99. Am I right? Yes, 99, 101.6, 96, 101.1. In the third year, 101.1, 100.7, no, 100.7, 104.4, nothing for the last 2. So the average, add them up and divide by 2. Quarter 1 have been 99.8%. Quarter 2, 103%. Quarter 3, 95.6%. And finally quarter 4, 101.5%. I think they're right. And the way we'd forecast, instead of simply adding or subtracting the variation as we did when we used the additive model, what we'd do is forecast the trend. We'd adjust by, if it was a quarter 1 forecast, taking 99.8% of our forecast. If it was a quarter 3 forecast, taking 95.6% of our forecast, and so on. And that gets around the problem I mentioned before, because if sales are growing a great deal, if the sales are twice as big, using this approach, the variation will be twice as big as well. One tiny thing, then I'll shut up. I said before, when we had the additive model, the seasonal variations should, in a perfect world, add up to 0. because there were differences from averages. With the multiplicative model, what ideally would they add up to? Now, some people shout out 0. Just looking at it, obviously nothing like adding up to 0. Now, surely because some are a bit more than 100%, some are a bit less than 100%. In an ideal world, they'd add up to 400%. Here, I'm not going to check. Here, they almost certainly won't be exactly 400% because, again, the first 2 sales quarters, the last 2 quarters, were used in our averages, but not in the variations. So there we are. Off you go and have a look at the practice questions for this chapter.